As we can see from the graph, EPOC has three major components: alactic recovery, lactacid recovery, and metabolic needs. During moderate and heavy exercise, glycogen stores are decreased significantly. Therefore, the slow component of recovery would take longer than light intensity exercise. In 800 metres, this can take up to 2 hours. Furthermore, as the lactic acid system is used, more lactic acid is produced, which is dealt with in slow recovery, so this aspect may take longer. Fast recovery would be a similar time, however breathing may not be as deep when an athlete has just completed a 100 metre sprint. In an 800 metre event, there will still be an oxygen deficit as your lactic acid system is anaerobic, therefore oxygen needs to be paid back, which occurs in EPOC. In order to improve your 800 metre time and be the best athlete you can, you must undergo training. This training should push you, however, if you're not used to this level of exercise, then you can suffer from delayed onset of muscle soreness, also known as DOMS. This can be caused by overtraining. DOMS is caused by myofibril tears or muscle strains from eccentric or unaccustomed exercise. This leads to an inflammatory response which can be displayed as swelling or altered muscle firing patterns and pain 24 to 48 hours after. Muscle strength and motion are also impaired, and light moving and passive stretching can help. Furthermore, overtraining is defined as exercising at a level beyond normal physical tolerance limits when the body is unable to recover adequately during rest periods. Symptoms of this include tiredness, poor motivation, and sleep. The causes are varied and include possible pressure from parents and coaches, possible exercise addiction, or an imbalanced training program. The physiological effects are an imbalanced endocrine system. Overall, this can lead to an effect on an athlete's performance. For example, the standard may become poor or inconsistent. You may develop a poor immune system, so you're more at risk of illness, and you may become more susceptible to injury. Additionally, poor sleep can lead to psychological impacts. In order to aid recovery and training and after events, such as the 800 metre, a high carbohydrate diet is essential. This speeds up the process of glycogen recovery. Muscle cells are most receptive to carbohydrate during the first 2 hours following a training session. Therefore, to accelerate recovery, consume 300-400 calories of carbohydrate shortly after and another 300-400 within 2 hours. Massages and ice baths also aid recovery. Moving on to submaximal exercise. The characteristics of submaximal exercise include a high VO2 max, fractional utilisation, which means oxygen is used more efficiently, a high power output at lactate threshold, muscle oxidative capacity using oxygen, economical technique, fat oxidation at high power outputs, being more fatigue resistant, and oxygen delivery, which is a determinant of VO2. Furthermore, RER, you would have an RER of around 0.7-0.8 in submax exercise. This is calculated by oxygen over carbon dioxide. At submaximal intensity, around 75% of energy contributed is fat, with the other 25% being carbohydrates. Therefore, fat stores will significantly deplete. Also, during submax high duration exercise, as liver glycogen levels become depleted, blood glucose levels decline. Lowered blood glucose availability is associated with reduced rates of carbohydrate oxidation and fatigue. Increasing glucose levels by carbohydrate ingestion increases carbohydrate oxidation and enhances endurance performance. Glucose could also be increased by the Cori cycle, which uses lactic acid and converts it to pyruvic acid, then glucose. This process is called gluconeogenesis. And reduced glucose could lead to fatigue, so this process is essential. During submaximal exercise, body temperature will increase. This is inevitable, and therefore it's vital to stay hydrated, as this can help reduce your body temperature. Your hydration level also affects aerobic capacity and performance intensity. Submaximal exercise also causes an increase in cardiac output and ventilation rates, which will help remove the carbon dioxide produced. This can be removed in one of three ways: carried in the plasma as carbonic acid, carried by hemoglobin as carbohemoglobin, or just dissolved straight into the plasma. In order to combat fatigue in long-duration exercise, early studies from Scandinavia show that carbo-loading can improve endurance exercise performance in events lasting longer than 90 minutes. This is because muscle glycogen availability is very important. Carbo-loading works by reducing the amount of carbohydrate consumed 6 to 3 days before the event, so the body thinks there's a problem with its glycogen stores, and then when it next can, it should store more glycogen than normal. Next, within 3 days of the event, consume lots of carbohydrates, and the body will replenish the glycogen stores and should top them up with extra. In an epoch graph for steady-state exercise, you can see there's a small oxygen deficit, and the competitor reaches steady state, which is where the VO2 required for exercise is the same amount that's used by the working muscles. Also, as the majority of exercise is aerobic and there is less use of the lactic acid system, then there is less oxygen debt. This results in a quicker recovery, which means less oxygen is consumed in epoch. It also means alactic recovery may take less time. Finally, we have intermittent activities, which involve short bursts of very high intensity exercise with rest or recovery periods in between. This type of activity uses the ATP-PC system and possibly the lactic acid system if the maximal activity lasts longer than 10 seconds. This means ATP is broken down into ADP before being resynthesized by PC, with ATP being adenosine triphosphate and ADP being adenosine diphosphate. PC is also phosphocreatine. Once exercise is finished, PC is resynthesized and stores are replaced in recovery. In order for muscle contractions to occur in this exercise, acetylcholine is required to transfer the nerve impulse across the synaptic gap at the neuromuscular junction in order to initiate muscle contraction. A muscle will only contract if there is enough ACH, therefore insufficient ACH supplies arriving at receptor sites means muscle contraction cannot proceed and fatigue will occur and will be displayed within different sports. This means a depletion in ACH stores reduces performance. Furthermore, cholinesterase is an enzyme that breaks down ACH after it's rolled and prepares it to be used again. In order for another muscle contraction to occur, the synaptic cleft has to be cleared of all ACH by the enzyme cholinesterase. Fatigue occurs when there is too little cholinesterase, but also when there is excess, as there is an inability to generate a new action potential. These effects cause fatigue in intermittent exercise, as the neurotransmitter is destroyed by the enzyme in a short amount of time, preventing further contractions. Calcium ions are vital in the sliding filament theory, which causes muscle contraction. During the contraction phase, calcium ions are released into the cell, causing filaments in the muscle fibre to contract, which causes muscle contraction. In muscle relaxation, calcium ions are pumped back into storage, allowing the muscle filaments to relax. However, when muscles start to fatigue, the storage, which is the sarcoplasmic reticulum, begins to leak calcium ions, which causes muscle contractions to become weaker. In terms of recovery, the higher the intensity, the greater the effect of epoch are. As intermittent activities such as games are short bursts of high intensity, for example football, you do lots of little short sprints, then epoch will be high. These short sharp sprints will also deplete your PC stores, which take approximately 120 seconds to recover. This means in this time you'll be fully recovered, ready to complete another sprint. From the graph you can see that PC levels don't fully recover each time, which will be displayed as fatigue and also cause a reduction in power. In order to improve fitness for interval exercise such as football games, we use interval training. Correct recovery periods can be used in order to improve energy system adaptations. Furthermore, training can increase ATP-PC stores slightly, and also you can use PC supplementation as discussed before. Intermittent activities will also cause a build-up of lactic acid, which can take several hours, if not days, to recover from. Thank you for watching.